Hello and welcome to today's webinar, BIM for CAD users. This will be covering the civil and survey workflows inside of BricsCAD v26. My name is Samuel McAllister and I am a senior solution consultant for BricsCAD in ANZ. So key learnings under today's agenda will be in three parts. Number one, we'll be exploring different data sources. We'll look at the geographic location setup, how to coordinate between BIM softwares and CAD GIS, and how to use the data in a CDE, a common data environment. We'll then move on to SiteWorks. So we'll look at how to create tin surfaces from various sources. We'll work with some of the symbol styles that are in BricsCAD Pro. And then we'll look at some of the annotation tools for line, area, and boundary labels. Finally, for part three, we'll look at some of the civil design tools covering corridors, grading, and then some of the basics for building information modeling with BricsCAD BIM. So section one, let's look at data. In this webinar today, we're going to be covering some data sources from a free data source in New Zealand from Auckland Council. We'll also be looking at ArcGIS information. So you can go to the ArcGIS location platform site, sign up for free, and bring in aerial images into BricsCAD Pro via the API key. Auckland Council GeoMaps will be getting a lot of data for free from their website, including Esri shapefiles, DWG, and high-res imagery. And finally, we'll look at open topography. This has highly detailed point cloud data, which will provide you up to 1 meter for the digital elevation modeling workflows. It also comes in classified, which you can leverage inside of BricsCAD Pro. So if you go to the ArcGIS website, you can follow the steps using what I would recommend Google Chrome to generate an API key. It's free to sign up, but follow the steps carefully. It may take some attempts. Sometimes the pop-up for the API data doesn't pop up on their website, so just make sure you follow that to get that API key. Once you have the API key, just save it as a text file on your desktop in a location. It will last for 3 months or more, and you can cut and paste that key into BricsCAD, into the online map support. And when you come to use online maps with the geolocation, the Esri imagery will show up. So here inside of BricsCAD Pro, we can start a new drawing. So this is the civil survey environment for BricsCAD. You'll get the Civil Explorer, and under your Insert tab, you'll have the geographic location set up. Now, if it's not loaded for your particular GIS coordinate system, you can download more information as needed. We can search through the database. So we have the NZTM. We can load that in and use that as our geolocation to work from. Before we bring in the ArcGIS API, we want to set the location. So we need a shapefile or some sort of data to work off that is geo-coordinated. So here we go to the Civil Explorer, import GIS layers, and we can bring in shapefiles or KNZ files, other file formats. We just want to start with the basics. So we're going to bring in some contours in 2D, set the import polygons as polyline, zoom extents, and now we have some 2D contours showing. This is purely just to check the alignment of our online maps with our GIS location. Here under GeoMap, choose Esri imagery. And here we have the map linked in via the API key. And we can zoom out as far as we want and know that it's correct within the GIS world coordinates. We can also use the inbuilt free one, which is OpenStreetMap, to double check. And you can see it's lining up perfectly. So it's a quick and easy way to leverage a free tool to locate imagery inside of BricsCAD Pro. Now, depending on where you are, depending on where you work and what geo, what city, the government or the councils or the municipalities will provide data for free up to a point, or you can pay third-party suppliers. In this instance, we're looking at Auckland in the North Island of New Zealand. You can see the extent of data they have made available for free. It covers items like property boundary lines, building footprints, parcels, curb lines, wastewater, stormwater, etc. There's a lot you can extract for free from their website. So if we want to bring the data in, we've already set up our coordinate system inside of BricsCAD. We go to the Auckland City Council, and you can see the extents of what they provide. We're going to navigate to the site that we want to work on today and select the area and the layers to download. So there's a lot of information you can get, and we can set the coordinate system. So we're working to the NZTM. We can choose KML, Geodatabase, DWG. We're going to work with Esri because it has metadata. We put in our email, download the data, and then we can bring it in via the Civil Explorer GIS tab here. So I'm going to get all of those shapefiles except for the contours that we brought in before. Again, bring it as a polyline. It's just easier to work with at a later stage. And you can see here, everything comes in on layers ready to go. We also have high resolution geolocated imagery. So if we bring this in, you can use that geocoding information, the JGW file, and that will position that aerial map aligned with the contours. Open Topography has some great data sources, free point cloud files, high resolution, a lot of detail in that high resolution topography. And depending on where you get the data from, it will have classification information as well, which can be very valuable for working inside of BricsCAD Pro. So on the Open Topography website, we can go to find data map. It will start off centered on America. We can navigate down to New Zealand and navigate down to our site in the Auckland waterfront here. And once we're happy with that, we can select a region. You'll see on the right-hand side the data sources that it can provide. Again, this is going to come down to what's available in that particular city, that geo. So we've got the high resolution topography tab and then open topography. You'll find maybe not all of the data is there, like there's no LiDAR data, but under open topography, you can download that point cloud information almost for the entire CBD of Auckland, which is pretty impressive. You can bring it in as an LAZ file format, a native point cloud file format inside of BricsCAD. You don't need to convert it. You add your email address, sign in, and then once it's downloaded, we can go to the point cloud tab, attach the information, let it process. Again, it doesn't have to be converted. You can work with an E57, an HSPC, LAS, LAZ, etc. All of these raw native point cloud files can be loaded into BricsCAD Pro and you can use that to start to generate tin surfaces. You can classify the information. You can turn on and off layers. You can really work with it in your way that you want to. So here we have the point cloud. Now this is a big point cloud. This is a large part of Auckland, so going beyond the CBD out to the West Haven Marina area. We can go to the color map and leverage the classification information. Here we have LiDAR classification or 3DR classifications. You can change the colors as needed, set up more colors if you need to. There is also a classification tool inside of BricsCAD if your point cloud or your data is not classified. This one fortunately is, so we can go to the point cloud manager and we can start to remove information that we don't need to see in the viewer. So we can turn off the unassigned, the high noise, and the low point. And now we're left with vegetation, ground surfaces, water, bridge deck, and buildings. This one includes the sky tower. So a lot of detailed data is available right up to the CBD there, going beyond the CBD, including the motorway to the bridge, right down to the waterfront. So our particular site here, we can see it very clearly inside of BricsCAD. It performs brilliantly. And we can then start to use this point cloud, which is classified, to convert into tin surfaces, or we can crop it, or we can check it for other types of workflows. So point clouds work fantastic inside of BricsCAD Pro. Now, if we need to work with other applications like Revit for buildings, for architecture, we can work with coordinate systems aligned. So we can set it up between BricsCAD and other BIM applications which have a base point and a survey point. We can align the northings and eastings. Once that's set, we can double check the latitude and longitude to make sure we're in the right coordinate system code. And then we can collaborate between platforms with CAD and ISC data. So here inside of BricsCAD, we want to set a point that will work as our survey point. Now, this one, when we set that point, we have northings and eastings information here that we want to use inside of Revit. Inside of BricsCAD Pro in the civil environment, it works in meters. So you want to take that information and add it to the unclipped survey point. So you can see here, north, south, east, west. So adding our northings and eastings to those two components. So just a cut and paste. Type in M at the end for the suffix, and that will enter it in as meters. Put the paperclip back on to lock it in place, and we can link in that CAD file that we have from BricsCAD, and it's going to come in under the alignment, and when we zoom in we can see it is matched to our site here. So a simple workflow to keep an alignment of GIS coordinates between the two platforms. The layers come through, you can turn off what you don't need to see. And we can also test this by working up in Revit just some basic walls. Now you'll notice the walls are skewed. That's because inside of Revit there is a restriction on how far you can go with the GIS information. It still works, it's not a problem, but it's just sometimes skews the information. The GIS coordinate system code is showing up here. So we've done all that, and we want to export this just under the default settings as an ISC for Revit, from Revit, and then import it back into BricsCAD to check that alignment. We can bring it as an XREF, or I'm just going to import it because I want to look at the ISC information. You can see the walls have come through clean, so it's correct. It just displays better inside of the BricsCAD GIS information display. But the IFC information, the metadata from Revit, is showing up here inside of the BricsCAD environment at the right GIS location. Now, finally, for the data setup, we want to look at hosting the data in a CDE, a common data environment. So if we look at the Autodesk Desktop Connector, the ACC Construction Cloud, we can save direct from BricsCAD into the Desktop Connector. We can add other files into the cloud and reference them. We can easily view the 2D files, the CAD files, and the 3D files. They work natively on the CDE. And you can collaborate with other consultants using that platform. Also, you could work with the export of HSBC point clouds, which will register on the construction cloud. So simply, you don't need to do anything different if you're saving to a local area network. Same thing with saving to the construction cloud. Just save as to the desktop connector. You just need to fire up desktop connector. That will bring in Autodesk Docs into your browser, and then it's the same as working with a LAN. You just save it into the particular folder that you need to work in. So we're going to save that as a CAD file. And then here, once it's processed inside of ACC, here's our 2D view and here's our 3D view processed, easily readable inside of ACC. It also comes in with the tin information that was just on layer 0. So the layers are available and we can turn on and off the layers that we need to see. You can also select that information and then look at the properties. So it will start to give you information on the metadata as well that's come from the BricsCAD authoring package. Here in the 3D environment, you can navigate through the model. So the more you add to it, the more you're going to be able to see. You can do sections, you can measure items, you can look at more metadata. Here we have our tin and our contours showing in 3D on the cloud, and also the ISC that was imported in from the Revit export. And again, you can look at the metadata of that ISC information inside of ACC. So moving into part 2, we're going to look at the creation of the site works and do some annotation. First, we're going to start with a tin surface. You can work with numerous file formats. There's about half a dozen. We'll look at point clouds and contours today, but if you have different data sources, you can bring them in and leverage them inside of BricsCAD. You can also customize the amount of triangulations. So this one down here showing up in red is very detailed, so I can fine-tune all that information using the surface definition. And you can refine parts of the tin as needed. You don't have to do the whole entire model. So it's a very powerful tool for creating tins and then also working up tins. So if we want to create a tin surface, we just need to have the data to work with. So if it is a 3D CAD contour file, we can bring that in. So we're just going to bring in this one from the Auckland City Council that I downloaded earlier. And we just need to select the contours that are on that layer. So you can either isolate layers, or you can turn off layers, or you can filter through layers. We can then go to the tin surface and create from contours, select all the contours that we want to use, and then generate the tin. Now there's some default settings here. We won't get into all of them today, but here is your tin surface easily created from those CAD contours. Here, moving into the point cloud environment, we have that point cloud that is classified, so we can go to the classes and turn off the information we don't need. So we just want the ground information, and with that ground information, we can go and generate a tin surface. Now, the more detail you have in the point cloud, the more refined that surface will be. So here, just using the basic information, it will create a tin surface, and you can see the quality of that output. Now, you could get into the BricsCAD engine for refining that data. So under the Civil Explorer, you've got a few more tools that will allow you to either simplify or densify the point cloud. So Civil Explorer, here's our tin surface, and there are more options to actually edit the data, remove points, point locations, point elevations, extract data. You can do a lot more to fine-tune that data once it is brought into BricsCAD and converted to a tin. When we move into annotating our workflow here, our site, we can leverage Esri shapefile attributes. So this is the data embedded within the line work. We can use civil points to convert data from the CAD points. So we can actually grab those points and convert them into civil point styles. We can easily edit the label styles and symbol styles to our company standards. We can work with blocks as well. We can customize and reuse our own existing blocks if you want to do that inside of BricsCAD. So here I have some plots and parcels and some stormwater line work. It's a little bit hard to see, but we also have some points that represent stormwater manholes and chamber pots. I want to take these points and add symbols to them. So I'll get rid of the other layers that we don't need and just isolate the layer. And here you have the points. So we want to convert from CAD points to symbols. Here we'll go and get all the entities within that file, and we'll go and convert them into symbols. So this has actually happened on the layer 0. We can move it on to the correct layer, and once that's set, we can then adjust the symbol styles. So we're just going to select similar, nice quick way to do it, and then move it to the stormwater manhole and chamber pot layer. Now, these ones are set with no Z value, hence why they're just showing up as 0.00, but if you had Z values, it would record that within that symbol style. Here, under the settings, you have access to all the different styles, but you can also do it via the properties tool here inside of BricsCAD Pro. So we're going to edit that style, and we can customize it from here in the symbol style tool. So we'll just rename it. It's at default at the moment. Again, you can duplicate these and edit them as your own preference. So we'll just call it stormwater manhole, SWMH. And then if you need to, you can bring in a block. We're just going to work with some of the out-of-the-box symbols available. You can choose to have a circle frame, a square frame. The custom symbol size can be an X mark, a cross, a dot, a line. These are just basic ones that are embedded within BricsCAD Pro. And now when we do that, you'll see it update within our drawing. So a very simple, quick and easy way to add symbol styles to the metadata that were brought in to BricsCAD. So now we're going to move into line labels. You can annotate lines quickly once set up with the code data. You can reuse this existing content from other styles as needed. You can easily search through the property entities as well to align that code data with metadata from the line styles. And you can bring in a suffix or a prefix like alphanumeric bit of information before it actually labels that particular line work. Other things, you can flex the borders, the arrows, the offsets, and rotations to suit. So we're going to look at some stormwater pipes first for doing the line label styles. Here, I'm just going to duplicate one of the line label styles and call it SWP, stormwater pipe, and then put it on the right layer. By default, this actually has the bearing and distance code block. You can delete those, use them in other things. Here inside of the text content editor, we want to add some of the metadata from the GIS Esri shapefiles. So we'll search through to find the stormwater object information. And now we have that code block representing the text we want to show, annotating the line work. We also want to add an arrow. So you can have an open head style. You can adjust the Y and X offset. You can give it a color, put it on layer. So we've got a basic line label style set up. Here, we can just isolate that line work, and we want to apply that label to that line work. So we're going to choose the SWP, select all that line work, and we can see the outcome that we get from just using the basic test. Now, if it's not perfect, that's fine. We can go and manipulate it. So go back to the editor, and here as we do the line style editor, we can see it updating inside of the drawing. So we want to increase the offset. We want to maybe rotate or change the arrow size. This can all be done very easily and intuitively using the label editor here. With area labels, we can use this for doing parcels or building footprints. So in this demo, we're looking at the deposit plan for a lot, looking at the number and the area. We can reuse this content from other styles. We can set up as a template, and as we work with this, it will adjust with the drawing scales. Again, you can add that prefix, suffix as needed. Add the borders, the arrows, the offsets, and rotations. So we want to add an area label in this instance. So when we select that polyline, that Esri shapefile that we brought in, there's a lot of metadata available here relating to, say, the parcel area and the DP number. So we go to label styles, and we can adjust those area label styles by copying the default and then giving it a new name. We can then make sure it's going to go on the right layer, and you can see by default there is an area code here, but we want the parcel area. So we can type in parcel area, and that will give us a code, and then we can type in a prefix. So we want DP for deposit plan, and then for the area, we want that to have M2 at the end and area at the front. So we'll just start off with using that area tag, and you can see here it's picking up the information. Again, if it's not perfect, we can adjust it. So I'm going to add a bit of a code block here, just search for the particular code that we need, and make some spaces just for the DP, just so it reads a bit better. Maybe we want to add a border around it this time. Maybe we want to change the layers or add a curved edge to that border. All of this can be done based on the company standards to achieve the clarity that you want. So it's very easy to get started. If I go and change the scale, you'll see these will flex to suit. So it's a easy tool, set it up, use it on other projects, and it will automatically give you that information on the DP in the area or more data as required. Same for boundary layers. We can set up the bearings and distances. We can adjust these to suit. It can be helpful for more complex boundaries. So for a simple four-sided boundary or something with a crank or something really complex, this can be very powerful. You can adjust the text size and the locations of how you want that text to work offset from that boundary. It's very easy to edit on the fly as well. So if we want to do it for a more complex parcel, we can do that. If we just want to start off with the basics, we can do that as well. So we'll just go to our area labels and we're going to choose the BDY template that I've set up. So we're going to add that and select the entities that we want to do the bearings and distance on. Select that and let it run. And now we can see our distances and our bearings available. Now, if it's not looking right, again, we just go back to that line style editor and make some adjustments. So the bearing, that's the code block for the bearing. Got our degrees and our radians, etc., and we OK. It's showing up. We want to change the color and we want to change the text height of the distance. We want these matching so it's a bit clearer to read. And so maybe we want the distance to be bigger. Again, we can go and do things like add a suffix like a meter for the units, or if you've got this on your title block, again, you would have the unit set up. Now for something more advanced, this is using the tool for a more complex boundary. So you've got your distance and your bearing. We'll just make the text height a bit smaller. And if we go and again use the tool to add it, choose the boundary style, BDY, and now it's gone and added it. Now that's a foreshore property, so maybe we wouldn't have that exactly as our boundary line, but you can see it can be very detailed. It works with the Esri shapefile data and generates your distance and your bearing information. So we now move into the final section of our webinar covering civil design. So we'll be looking at some of the basic features inside of BricsCAD Pro. So we'll start with corridors and how you can use string data and alignments to generate a corridor from templates. We'll work on the tin surfaces. We'll use the standard templates. You can customize and make your own templates as needed to sweep along the different stations of the corridor. And as we update them, it will update inside of the corridor. So with this tin, we have an aerial map that we got from the Auckland Council. We can apply that to the tin just so we have some reference information to work with. Now this is just going to be a basic 101 demo. We're just going to pick a point using the alignment tool. Again, if you have more information or you want to do more with strings, there are third-party tools like Stringer Topo, which can really help with these type of workflows. So here, I'm just going over the top of where the road or the corridor is on the tin, just using the surface snap. And you can see it's followed the information of the tin surface. We can then just go and turn off layers we don't need. We also have the raster area image. We can hide that as well. And we now can sweep a corridor over that alignment. Now, this is some they've created before. We can choose the station start points and end points. We'll just do it across the whole part of the alignment. And now we have a corridor generated from that template. So very basic and simple. However, we'll be touching on some other tools at the end, which allows you to do more advanced corridors. New for V26, we have corridor sections. So BricsCAD Pro will allow you to do this. You can customize the styles and the intervals where it does the section cuts for the corridor, adjust the station ranges, generate numerous sections in 2D off that 3D data, that 3D tin and corridor. And when we make changes, it will update instantly. So we've got our corridor here. We can go and generate section views off that corridor. We just want to, first of all, generate some section lines. Now, I'm just going to use the basic default settings here. So I'm going to pick that alignment and let it generate it. So we're just going to choose the alignment or string. So we'll just choose the first one here. And I'm just going to use some of the basic out-of-the-box section line tools. So we can adjust the widths, we can adjust the section line information, we can adjust the station range. So you can go through and adjust this or add information as needed, adjust your increment information, and then create. Now this has generated the section lines, and here they are showing up with the tin surface turned off. So once we have those section lines generated, we can go and generate section views. So we'll just grab the part of the corridor. We'll go and get that information. We'll just use the basic section style. If you do need to adjust it, again, like the labels and the points and line type annotation tools, you can adjust these as per the output you want, even how it displays the minor and major labels. So we'll create this, and it's going to ask for an origin point for that section view. And then here we have those sections generated in 2D from the 3D tin and corridor, and it's named, and it has information on our major and minor labels, and this can be further fine-tuned as per your company standards. Grading is really easy inside of BricsCAD Pro. You've got an easy cut and fill tool. You can work with a polyline for the area that you want to cut or fill, and you can set the slopes instantly. So you can adjust those angles. You can go to the properties tools and adjust them. You can move the cut up or down depending on whether it's a fill or a cut, and we can look at the stats and analysis. So I've got a simple polyline on my tin, and I'm going to go to the grading tool, and with that polyline selected, the grading tool asks me to select a surface, and now we have the entire length we're going to choose, and you can see here it is providing an option for the angle we want. So if I type in, say, 15, which is quite a shallow slope for the grading, we've got that now set up as a fill on top of the tin surface. If we need to adjust it, we can do this. So if we go and navigate to the polyline here and we want to adjust the Z value, we can go to the properties. You can see it's sitting at elevation 11 meters above sea level. We can drop it down to 3. And now that has gone from a fill to a cut, and we can adjust the properties of that cut. So we can adjust the cut slope to 70. We can adjust the fill slope as well if we need to go back to a fill. And we can go and look at the visibility and tin analysis. So we can turn the border on. We can adjust if we want to see contours within that cut. We can adjust if we want to see the points. We can adjust what we want our major and minor contours to be, the colors. All of this can be done as per your requirements. And then we have grading settings. So you want to make sure that things like the infill and boundary are turned on, so you can actually see the result of that cut. And then we can choose to turn on tin analysis for elevations and slopes and expand the grading stats to see whether it's a fill or cut. So you can see, of course, it's a cut and the amount of cubic meters we would need to cut out for that particular site. So a very easy tool to get familiar with. Finally, we move into some BIM basics. So we're starting to set up, say, some civil site information for our excavation. So putting in some piles and a retaining wall and looking at maybe pipe work. So inside of BricsCAD BIM, you can XREF in files easily, like the files from the civil survey environment, set up your building information modeling workspace, set up the database, set up layers, and then BIMify components. So there's a few little powerful tools inside of BricsCAD BIM which will allow you to grab data. So it could be from IFC or modeling data. You can do that and it will start to create it into information modeling components. So what I have here is just a basic bit of line work that I want to work with for my starting point. I've set up my spatial location managers for the amount of levels. I want to create a foundation slab. I can go and use the default settings. I can customize them as needed. All I'm going to do here is select that polyline and apply that slab. So that is set to the floor 0. And again, you can adjust all of this as per needed for your project. This is just a basic demo. Now we want to look at, say, a retaining wall. So I'm just using some reinforced concrete here. We can adjust this and make this more thick as needed. Just using simple snapping tools will allow you to generate that wall. And then finally, we want to add some piling. So here we can go to our floor plan and then go to the columns and choose the composition. So you can adjust this as required, adjust the radius. You can adjust how you want to set the anchor point. So we're just going to put it here, for example, and maybe it's not quite right. So we'll go to the opposite for your setup point. We can just put that in there. And what we want to next do is look at using the array tool around a shape to have those piles work around the retaining walls. So here we go and use the path tool for the array. So we'll select the column, we're choosing the path, and the path is that rectangle that we started with. It will go and generate columns around that path. So a very quick and easy workflow to do a slab, some retaining walls, and some piles inside of the BIM environment. If we want to add pipe work, there are add-ins to do this in more detail, but straight out of the box, we have some tools to work with 3D polylines where we can convert them via the library into BIM profiles. You can customize and add your own profiles as required. You can customize the materials as well as required. And then once this is set, you can modify and connect parts up. There's connect flow segments, structural tools, T-connect, L-connect to start to join up certain junctions of your modeling data. So With this workflow, we have a 3D polyline, just using the 3D poly tool. And you can adjust the vector points for the Z values as required. So if you need to have a certain fall, you can make that adjustment. All we want to do here is apply a profile under the structural MEP tab. We're going to go and choose something from the library. So in the library, you have different profiles for piping. You can look at all here though and go all again, and then you'll see there is more for HVAC and structural steel. So you can have your equal angles and I-beams, etc. We're just going to work with the piping filters, and we'll just work with one of the simple ones out of the central database. So I'm just going to choose a large pipe. And again, you could duplicate this and create your own one. You can save them out, have them in your own special database. So this one, we're just going to work with a basic circular hollow with the radius and wall thickness as set there, and apply that to the 3D polyline. Now you can make adjustments and quarter turn and rotate it, but if it's set up fine, it will automatically do that L connect, that junction of that pipe very easily. So once you're working with CAD line work in 2D or 3D, you can start to leverage these BIM tools to convert them into information modeling components. Now, if you want to enhance your civil site design workflows, we have a partner based here in Australia, CAD Apps, who's one of our elite partners who provides some fantastic add-ons for BricsCAD. This is their civil site design tool, and I'm just going to show a couple of snapshots of what they can do for stormwater pipe design. It has an AI project assist tool and a subgrade model manager tool. So a powerful add-on to BricsCAD that can help you with your civil site design. So to summarize the key learnings, the takeaways for today, we did this again in 3 parts. So the first part we covered today was working with data, geographic location setup, coordination between BIM and CAD packages, working with a CDE. We also looked at tools to create tin surfaces via point clouds and CAD contours. We used some of the symbol styles and the line, area, and boundary labels for the Esri shape metadata. And we finished up with some of the tools for civil site design, including corridors, grading, and building information modeling. With that, I want to thank you for your time and attention, and we're going to open up the floor to Q&A. If we can't answer it today, we will send or get in contact with you by email and give you a definitive answer, but we'll open up the floor now and see if you have any questions based on the content we demonstrated today. Thank you.